Hello guys, my name is Desmond and I welcome you to my lesson for today where we'll be looking at mathematics. Obviously we're still on trigonometry. So good people, as always, please do allow me to say it is very much important that I say it is very much important because what I'm about to say it's massively massively important, ladies and gentlemen, that I say a day without learning something new, it's a day wasted. What I be saying? By so saying, please do make sure that by the end of each and every lesson that I conduct, you learn something new. Very much important, ladies and gentlemen, over there. So before I even go far, I would like to just make an indication that whoever who's watching this lesson, either on my YouTube channel, it could be TikTok, Facebook, or on any other social media platform, just make sure to subscribe, follow, like, comment in case if you've got any questions. But be aware that we are having a live lesson with the likes of Shreyas, Tumelo, Oratile, Ntabiseng, Determination. These are the learners who are currently on the line. So guys, are you happy there? Can you clearly hear me when I speak? And can you clearly see over there? Is it clear, guys?
Yes, sir, it is.
Yes, sir, it is.
Yes.
Okay, 100%. So I hope all of you guys did see the question paper which was sent in the group. So what I'm going to do is just to quickly read through the given statement, and then from there, I'm hoping to take you through the questions on that question paper. Let me try to pull out that question paper. I'm just not sure if you guys will be able to see, but I will try to zoom in at the screen. I'm just not sure if you guys will be able to see. Can you guys see there, or is it blurry? I think it's clear today. Can someone tell me if you are able to see over there?
Yes, sir, we can see.
It's 100%, isn't it?
Yes, sir.
Yes, sir.
Okay. Let's see. So, question number 5 says in the diagram below, T, remember, letter T represents a point. X and 15, those are the coordinates. So T, having an X value being referred to as X, Y value being 15, is a point in the Cartesian plane such that OT is equals to 17 units. Where is OT? There is O, there is T. So they're saying OT is equals to 17 units. P, having the coordinates of X being -2, Y being A, lies on OT. Where is OT? There is OT. Remember, O from the origin being 0, T being that point, forms a straight line. Point P lies on that straight line of OT. Very much important, ladies and gentlemen, over there. So K, where is K? Okay, there is K. It's a point on the positive x-axis. Okay, yes, that we understand. And T-O-K. Where's T-O-K? There is T, there is O, there is K. Obviously, it's a triangle, whereby the angle at O is being called angle theta. Okay, makes sense. So now, I think almost everything that was given on the statement, it is represented on the diagram. What I'm able to notice is that on the diagram, you don't have that OT being equals to 17 units. Remember, guys, everything is drawn on a Cartesian plane. So a Cartesian plane is where we draw a lot of stuff, and that includes the functions, the straight lines, or whatever. So in this case, as you can see, ladies and gentlemen, we've got a Cartesian plane where we have x and y. So now we have that straight line being O, and then we also have T. So with K being that point, when they say in triangle T, where angle O and K, so it's more like they're saying in triangle TOK. Where is that triangle? If you join that and also this, you form a triangle whereby the angle of O is referred to as angle theta. So that's what they mean by that. But from our side, we know very well that because we notice that we have a right angled triangle in the second quadrant, we can therefore make use of sine, cos, tan, and theorem of Pythagoras to find all these sides, just in case if we are not given those sides. But I'm not sure. Do you guys remember that they've actually given us this side and they said is 17 units? I'm not sure if you guys are aware of that. And also we've got T being x and again 15. This 15, good people, something that you must be aware of. That 15, it's actually from the origin going, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means from the origin all the way up to there, it's actually equals to 15. But now that x is from the origin all the way up to there. And that x value is given as x. So if we had to try and find all the information regarding that right-angled triangle, we might need to use either sine, cos, tan, or a theorem of Pythagoras so that we are able to complete the triangle. Very, very much important, ladies and gentlemen, over there, that at all times you pay full attention to all the details. So, ladies and gentlemen, do you now allow me to move to our very first question? Is there someone who's got a question based on the given statement and the diagram, and also based on what I've explained over there? Anyone who's got a question, guys? Yebo no maka.
No, sir. No question, sir.
Last one to confirm, Pungwai. Onalipuchisho. Curious.
No, sir.
No questions, sir.
Okay, 100%. So now I'm going to remove all of that. And then from there, we'll try to have a look at our very first question. So let's see. What is examiner saying there? So can you guys see that? In this case, examiner saying determine with the help of a diagram the following: the value of x. And this question, it's allocated 2 marks, which means it is not that much complicated. Do not complicate what seems to be easy. Just apply all the information that you know. Good people, is there someone who wants to give it a try? Remember, you just mention your name and I will recognize you, honorable member. So the question wants you to determine the value of x. Anyone who'd like to give it a try?
Tumelo, sir.
Dumelo has mentioned their name. Anyone who also wants to give it a try? Dumelo yaka, dumelo, dumelo, dumelo yaka, dumelo, dumelo, dumelo yaka, dumelo, dumelo yaka. Hey, Tumza, babalekile labantu ba, masikhuluma. Sisebenza kanjani le ndaba le?
Sir,
Mhm.
like we're gonna use Theorem of Pythagoras. Sir. Since
I thought you wanted to
elementary,
say we're going to use pi. Hey. So, sebenzisa theorem of Pythagoras. But why? Why theorem of Pythagoras? I don't understand how. Pythagoras. Tumza, I don't understand ukuthi ingena phi theorem of Pythagoras.
Sir, I'm we've given two sides, which is OT and the Y value.
Oh, I think you have a point. I think you have a point, Tumza. So you're saying we have OT being 17 units, and then we also have from there to there being 50. I think you have a point, Tumza. I think you have a point, because now we can say 17 squared is equals to from there to there being x squared plus 15 squared. Then you work it out. Obviously, we're going to have plus or minus. What is that value inside there? 64, yes. Okay, so what is a square root of 64? What are you guys getting there? 8. So that means we have plus or minus 8. Which one is correct between the plus and the minus?
It's a negative, sir.
So that means we have our x value being negative 8. Let me just write it down over there. So that means we have our x value being a negative 8. I'm not sure. Did you all understand, and do you agree with that? Tumelo yaka.
Yes, I do.
Tumelo. Oh, tumelo.
Yes, we do.
Tumelo. Tumelo yaka. Tumelo. Tumelo yaka. Tumelo. Hey.
Tumelo yaka.
Tumelo yaka. Oh, Benja, it doesn't end here. You know, I was trying to remember this song. Ke ba aringa. Hangi ke kailasha. Tumelo yaka. Tume. Hangi ke kailasha. Tumelo yaka. Morena Jesus, Morena Jesus. So, hey, Tumza, your name reminds me of this song. A very, very nice song. When we would go to some school trips, we'd be singing this 5.1.2. Determine with the aid of the diagram tan theta. This is 5.1.2. They want you to determine tan theta, and this question is allocated a 1 mark, as you can see over there. Anyone who'd like to give it a try, remember, you just mention your name and you will be recognized, honorable member. Ha ke kae lahla tumelo ya ka, 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 tumelo ya ka. Hey, guys, are you dancing for the song or are you thinking about the question? Which one is the which one is which one? Libandla la kaNkulunkulu senza njani masimo sinje? Determination. Was it No. Lebza, where is Lerato? Ubalekile lo mntwana lo. Uthi ukhathele.
Akanadatha se.
Oh, okay, no, sengiyabona. Manje ngoba wena unedatha senza njani lapho? Hey, ubalekile ngenyawo zobili. Okay, so ladies and gentlemen, what is the trig ratio for tan? We obviously know very well that the trig ratio for tan is y over x. What is y over there, good people?
It's 15, sir.
15.
What is x?
Negative 8.
Yes, it's -8. Can we further simplify this thing or it just ends as this?
We can't simplify, sir. It ends.
We can't simplify. It just ends as that. Easy, 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 easy. So you just get your 1 mark for doing that. Does it make sense, guys?
Yes, it makes sense, sir.
Okay. Can we now try to move to 5.1.3? Okay, let's see. What is examiner saying there? Examiner is saying determine cos into 180 degrees minus angle theta. Let's see. They want us to determine cos of 180 degrees minus theta. So can you see? That means, good people, what we can do, it is just to reduce that angle, because we see it's 180 minus that. Here comes a question. In which quadrant does this angle fall? 180 degrees minus theta. In which quadrant? Is cos positive or negative in the second quadrant?
It's negative, sir.
So that means we have negative cos of angle theta. So now, what is the trig ratio for cos?
It's x over r, sir.
Which means we have negative, which is that one. Then we have what is it? X over r. So now we have that negative. What is the value of x and what is the value of r?
So the value of x is -8 and the value of r is 17.
So that means we have a negative 8 being x and then r being 17, which means this times that it becomes positive. Then we have positive 8 over what is it? 17. So this question was allocated 2 marks. So that means you are most likely to get your mark for reducing that correctly and also for your final answer. Are you guys happy with that calculation, guys?
Yes, sir, we are.
Yes, sir.
Okay, so now we move to 5.1.4. Let's see. Sine squared angle theta. So this is what examiner wants you to determine, as you can see over there. And this one, it's allocated, what is it? It's allocated 2 marks. So anyone who's got an idea of how can we approach this type of a problem? Sarafina.
So,
Go for it.
so aren't you gonna say like open bracket sine theta close bracket squared?
Yes. So this thing, to write it nicely, is the same as that.
Then sine is opposite over hypotenuse, which is y over r close bracket squared. Then it's equals 15 over 17 squared. Then the answer is 225 over 289.
225 over 289.
Yes.
Do you guys agree with this calculation? Or does it even make sense?
Say 225 over 289. Ga re dire ka di-decimal.
Oh, no. It's fine as a fraction. If you remember, they said with, let's say they said with the aid of a diagram. Sometimes they might say without using a calculator, determine the following. So it's fine as that, as long as you cannot further simplify this by finding a common fact, you can just leave it as a fraction. Nay.
Okay, sir.
Who was asking that question? But everyone else, does it make sense, this thing? Are you happy there?
Yes, sir.
Okay, 100%. So now let's move to 5.1.5. Let's see what are we having there. So can you see, examiner says determine the value of alpha. Otherwise, if it's A, you can just regard it as A. It's fine. Doesn't really matter that much. As long as we know that is the value that we're looking for. Okay, so now, how can we find that value? Good people, how can we find that value?
I'm not sure, sir, but I think you're gonna use Theorem of Pythagoras.
Okay, let's go for it. How can we apply theorem of Pythagoras in this case?
Say I forgot to write the value of x. So what was the value of x before?
You mean that one of, oh no, that it's -8. The value of x is -8. So remember, I was about to say, in case if you are on the podium, you can just leave your mic unmuted. So there won't be a need to mute and mute. As long as we are now communicating, you can leave it unmuted. You can continue. You started with h. So is it h of x? Are you saying h or h? Which one is it, honorable member? Determination.
Yes, sir. I'm still
Uh,
thinking. I'm still seeing how
oh,
am I going to do.
you're still
Yes.
okay. No, it's fine. Anyone who think it.
So
Mm-hmm.
I'm getting like the value of P, but
Mm,
as -2 and alpha, which
mm.
is like the value of x from that triangle. Yeah. From that triangle OP, the negative 2, it's -2. The x value of
Oh,
the
so
aspect of
so it's more like you are saying from there to there, it's -2.
-2.
Yes,
Yes.
yes.
Then and ish the hypotenuse, I think it's gonna be half of OT.
Half of O.
T.
No. So on that
Because
one,
alpha seki y value.
okay. So on that one, the Tumza, I would only agree with you if that x, for example, it was -4 and not -2. So remember, let's say -8 is there. So this -2 is there. So for example, it would be half if maybe that point P was there, somewhere there, whereby x is -4. But can you see where it is? It's actually down there, even though I haven't drawn it to scale. But let me just bring that sketch. You will see. Can you see that there's no way from origin to P could be halfway between origin to T? Can you see there, Matumza?
Says.
Uyayibona manje.
Okay, so what if we get angle theta, and then
Mm.
getting angle theta, then because we have one side, then we're gonna use but again trig ratios.
You have a point, honorable member. You have a point. So what Tumza is saying there, she's saying, what if we try to find this angle? Because we already know this side is actually -2. And then from there, this point being P of -2, and let's say it's A, that thing. Then it means, remember, A is actually that vertical side, the opposite. If we find the angle, then we have two things. We can calculate the third thing. But how can we calculate this angle, honorable member? Lona barata pila. Are you guys still cabanging there, or have you cabanged? Which one?
Yes, I'm still thinking and I'm there. Please give me a minute.
Hey, you've been cabanging, You've been cabanging since yesterday. Are you still cabanging? Who's that? I praise not determination. Who was it?
Yes, please. Determination.
Hey, I determined that it was determination who is still cabanging. Shreyas, are you also cabanging there? Or are you watching a movie there?
Yes, I'm still thinking, sir.
Okay. Let me give you a hint. Honorable members. So can you guys see that we actually have a triangle within a triangle? Actually, let me say a right angled triangle within a right angled triangle. So my mind tells me that I just forgot that rule or that theorem for triangles. But if we have this big right angled triangle and we also have another one within that triangle, we can maybe say, let's say this one is y1, and then we will say over y2. So y1 is from there to there. Then we'll say over there to there. And then we'll still say x1, which is from there to there, over x2. Then we try to find the sides. Y1 being 15, Y2 being, what is Y2? From there to there, it's actually A, because that's what we are looking for. And then what is X1? Do you see? X1 is from there to there being 8. Of which in that case is -8. Okay, it's fine. And then now this one is what is -2. I'm not sure if I'm making sense there. So it's more like we have 15 over what is a y2 is our a. Then we equate it to a, what is it? The bigger one being -8 over the smaller one being -2. I might not have correctly applied that law or that rule, but to me, it's just the ratio of saying y is to y, and then we equate it to x is to x. Then I solve for a. Let's see. I just cross multiply. Then I've got 15 times 2 is actually -30, considering that negative. And this times that, it's actually -8a. Then if I divide by -8, I divide by -8. That cancels that. And then I have my a being equals to. What is that ratio there? Let's see. 15 over 4. So we are having 15 over 4, which possibly mean A is actually equals to 15 over 4. I'm not sure if you guys understand that calculation. Does it make sense, guys, or am I losing you there? Mm-hmm.
It does.
Guys, are we still together there?
Yes, sir.
Okay, so let's try to check another method and see if it can work. Let's try another method. So we have this straight line having the coordinates. There is t. We have t there. What is the x value at t? It's negative 8, and then y being that. And then at that point p, we know this is negative 2. Let's say a is what we're calculating. Guys, the origin, it has the coordinates, is 0 and 0. Never forget that. So now, this is what we call a collinear, from there straight up to there, extended up to there. That means the gradient of this segment and that segment is the same, because this is a straight line with a point which lies on that straight line. So that means the gradient of TP is equals to the gradient of PO. And again, the gradient of OT is equals to the gradient of TP or PO. So what I'm actually saying is that I can calculate the gradient of OT and say this is equals to the gradient of OP. I hope you guys know the gradient formula. So that means it's going to be your y2 minus your y1 over x2 minus x1 being equals to y2 minus y1 over x2 minus x1. Let's see. OT, let's substitute. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y. Okay, this being the second values, this being the first value. So what is y2 there? Is it not 15 minus a 0 over a x2 being negative 8 minus a 0? This being equals to a, let's say p is the second values. So that means we have a y2 being a minus 0 over a, what is x2? x2 being negative 2 minus 0. So 15 minus 0 is what? Is 15 over negative 8 minus 0 is what? Is negative 8 equals to a minus 0 is a, what is it? 0. This man, no, a. Negative 2 minus that is negative 2. So all that you do is just to cross multiply. So it's more like you have a negative 2 times that. So you actually have negative 30 over negative 8. This is going to be equals to a. So what is negative 30 over negative 8? What is that?
It's 15 over 4.
It's 15 over 4. So can you see, it gives me the confidence to say this answer is correct, because I've tried to apply two methods to try and calculate that. Did that make sense to everyone? Are you guys happy with that calculation? Tumelo yaka, tumelo yaka, agigi kailasa, tumelo yaka. Guys, Are you happy there, or did I lose you?
So I'm happy, sir.
Okay. I got an indication that all is clear. So now I'm going to remove all of this, and then we move to the next part of our question 5, which is 5.2. So I'll just bring the question on the screen. So let's see. What are we having over there, honorable member? So can you see? They say simplify without using a calculator. A sine of 120 times cos of 210 times tan 315 times cos 27 sine 63 cos of 5 what is that? 5 4 0. This question, it's allocated 7 marks. It's a lot of marks. Guys, I'm begging you this time around, please make sure that I'm copying it correctly. So it's let's see, it's sine of 120 degrees multiplied by cos of 210 degrees times tan of 315 degrees times cos of 27. All of this divided by sine 60 times cos of 540 degrees. Let's try to make sure, because sometimes I do write this thing incorrectly and we end up not getting anywhere. Can someone with a second eye confirm if I've copied it correctly?
Yes, sir, you copied correctly.
Ladies and gentlemen, let's see. Is there someone who can tell hore we etsahala eng? Show me hore re etsa jwang? I just want a feedback from any of you guys to respond to my question of how do we approach this type of problems. Remember, the question says simplify without using a calculator. So you can just momentarily put it away and then we try to solve this problem. Is there anyone who can tell what is actually the main aim, or what is the most important thing that you need to be aware of, or how do you approach this type of questions? What is a big deal there?
Sir, is to reduce the angles.
Easy, 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 easy. Thanks for that response, honorable member. So, which angles are we reducing there? And which ones are we not reducing? And why are we not reducing the ones that we are not reducing? And why are we reducing the ones that we are reducing?
So we're going to reduce the 120, 210, 315, and 5 volts. And the one for 27 and 63, we don't reduce because I see the special angles.
Which ones are we not reducing again, honorable member? Which ones? Honorable member? Who was speaking? Was it Tumza? Okay, so guys, she is 100% correct. We are going to reduce 120, 210, 315, and 540. We won't reduce these two. Whoever was speaking, the reason to that, it's not because they are not the special angles, but it's because already they are acute angles. They fall in the first quadrant. That is why we are not reducing them. So all these other angles, 120, that and that and that, we are reducing them to being acute angle. So we have 120, it falls in this quadrant, which means it's a obtuse angle. We have 315, we have 210 also. 210, it falls in this quadrant being reflex. We have 315, which falls here is a revolution. We also have that one which passes a revolution, goes beyond. So now that means we'll need to reduce all of those angles. So how do we reduce those? This is how you can possibly reduce the angles. There you've got sine of 120. In which quadrant does it fall? It falls here. So that means it's the one for 120 minus. So that means there we are having a, let me just create some space or write in small letters. We have a sine into 180 minus, what will it be? I think, is it not 60? I think it's 60. Just confirm for me. Multiplied by. So you just need to find an angle whereby when you say 180 minus that angle, it takes you there. And then now we are on cos of, where does it falls here? Cos is 210, which is between 180 and 270. So that means it falls, remember there is 180 degrees minus that angle. Here it's 180 degrees plus that angle. So that means is 180 plus. It's 180 plus what? I think
Plus
if you
30,
add 20, 10 years plus 30. So now we go to tan. And then tan, it falls here. It falls here. So it's 360 minus. Is 360 minus what? Is it 45?
Yes, it is. 360 minus 45.
Minus 45 times cos of 27. That one for now I can just leave it as it is. Why? Because it's already reduced. It's an acute angle already. So also sine of 63. 63, it's also a, what is it? It's also an acute angle. So when it comes to a 540, so it's more like you have an angle which started from 0, it went like 90, 180, 270, 360, but it didn't end there. It went beyond what is it? It went beyond 360. So what I normally do in my case is just to say 540 minus 360. So you're going to know that after it passes 360, in which quadrant does it end or does it land? What is 360 minus 540?
180.
It's 180. So that means this thing is actually the same as a cos of 180 degrees. So this part is there someone who's got a different explanation to this? How did they teach you guys at school where you have an angle which is over 360 degrees? Did they teach you guys differently when you compare to what I'm saying there? Or are you also doing the same thing at your schools?
No, sir, they did teach us exactly the way you are teaching us.
Okay, so that means we can now continue. Let me not remove this in the meantime. So let's see. Let's reduce this thing. In which quadrant? Already we know it's in that quadrant. Let's have that cast diagram. So we know only cos is positive, all of the trig ratios are positive, sine is positive, tan is positive. So in this quadrant, sine is positive, yes. I'm not sure if there's someone who disagrees. So it's more like we have sine of 60 degrees times, what about cos of 180 plus? 180 plus is here, and here it's only tan which is positive, then cos is negative. Very, very much important inside the brackets, write it as a negative value. So now tan 360 minus, it falls here, and here it's only cos which is positive. So that means tan is negative in this quadrant, tan 45 degrees. So now I'm having this one being a cos of 27 degrees. All of that over, what are we having? We still have sine of 63. I'm not sure, guys. Is what is it? Cos of 180. Do we not know what that is? Can we not work out that one? Is there someone who knows what is cos of 180?
So I think according to this thing, cos of 180 is -1.
So,
There.
Ori. Ah.
Who's speaking? Someone said Ohong. Who said Ohong? And that one is Spady, by the way. I can tell. Was it you, Shreyas? Who was it?
Who says?
Ohong.
I'm not sure. So now I said,
Hey, determination disappeared. That one who said Ohong, I think they noticed something. So I wanted to confirm if they agree with that statement of cos of 180 being negative 1, because indeed it is negative 1. Even if you try to verify on your calculator, cos of 180 is negative 1. So now all the angles have been reduced. How many special angles do we have over there, and how many are not special angles?
I think we have 3 special angles.
How many are not special angles?
So, 3.
Was that 3 or was it sorry? What was it? So remember, guys, for every response that you give, make sure to give a full response. For example, if you say you see 3 special angles, say 3 being 60, 30, and 45, then you can tell that a matriculant has spoken. If you say 3 of not special angles, specify so that you make a point and then there are no questions about your point. Here comes a question. How many special angles are we having there, and how many are not special angles?
So I think we have 3 special angles and we have 3 which are not special angles.
What are those?
I think 60, 30, 45 are special angles and 27, 63, -1 are not the special angles.
Okay. So the angles, honorable members, angle is only on sine, tan, and cos, and also on the reciprocals. Cosec, angle, this will be sine angle, tan angle, cos angle, cot angle, sec angle. So anything else is not an angle. So that means you have 60, 30, and 45 being angles. As you can see, they are in degrees. 27 and 63, these are the angles. As you can see, they've got degrees. -1, it's now a value. It's no longer an angle. But 180 is an angle. So the whole of this is the same as -1. So -1 is not an angle. Does it make sense there, honorable members?
Yes, sir.
Yeah. So
Yes,
now
sir.
we need to speak like what is it? Hey, usiami mo. Are you okay? Was it you, Tumza? Why timula kafu?
No, sir, it's not me.
Hey, you guys must not die. We need those distinctions, guys. Lungster, are you okay there?
I'm good, sir.
Lebogang, are you still with us?
Sir.
Grace, Shreyas, Tumsa, Determination, are we doing good?
Yes,
Yes,
sir.
sir.
Okay, so now let's continue. For the last time, good people, it is very, 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 very much important that you know those right what are they? The special angles, the right angle, the triangle of the special angles. It's very much important that you know them by heart. This one I'll never forget because it's easy. It's 1 square root of 2. This is the one for 45. And then I'll combine the 1 for 60. I know the bottom is 60, at the top is 30. If I remember, we have square root of 3, and then we have 1, we have 2. Am I correct there? Is that correct? You must know it by heart.
Yes, sir.
Because remember, they said do everything without using a calculator. Okay, so let's see. What is the trig ratio for sine 60? What is the ratio for sine 60?
It's √3/2, sir.
It's √3/2. Don't mute your mic. Let's try to continue. What about that one for 30?
It's √3/2.
Remember the negative. So it's negative
Ah,
√3/2. What about that one of 45?
it's 1/1, sir. -1/1.
Yeah, so it's negative 1 over 1. What about that 27? How can we work out that 27? Guys, expect this type of a question in some of your exams. It could be the one for preparatory or your final exam, where they want you to be using some special angles. They give an angle which is beyond 360, and they give you another angle which is not a special angle. So I'm telling you guys, how can we possibly try to change this angle from being 27 to being 63, or change this one of 63 to being 27? Because that is the trick with this type of questions. Lebogang, expect this type of a question, and when you get to this type of a question, remember that between 27 and 63, you can either choose this one to look like that one, or this one to have the same angle as that one. How can you do it?
Sir, I think you can say 90 minus 63. Cos 90
So
minus 63.
so you, let's see. Where here for cos or for this one?
Cos 27.
Okay, so that means this is the same as cos of 90 minus 63. Guys, is it true that 90 minus 63 is equals to 27? Yes. What is the question? What is the question? Who's got a question, guys? Guys, do you agree that 90 minus 63 is equals to 27, and therefore cos 90 minus that is equals to that? Do you guys agree?
Yes, I agree, sir.
Okay, so this one, you just write it as it is. So it means you either change that one or you change this one. If you were changing this one, that means you leave that one as it is. So that means here you're going to have a 90 minus
Sir,
27. Yes.
sir,
Yes. So,
sir.
what's your point? What's your point of order, honorable member?
Um,
You know, I've noticed in the past days that Grace is struggling with the network. Grace, I think straight away, if you get a chance to speak, straight away go to the question. Maybe I can hear it, because I can only hear you when you say, but the rest of whatever you're saying, I'm not able to hear.
sir, I think they're supposed to cancel each other, 27 and 63. Because earlier on,
Okay, Grace has got a
sir, I
point
think they're
over
supposed to
there.
cancel each other.
Okay, Grace, you've got a point, but you don't just cancel, because sometimes you might find that this has got a negative somehow, or this has got a negative somehow. It's not always where you just cancel them out. In some instances, yes, you might just straight away cancel them, but let's show how they cancel each other out. Let's try to work out that one. Let's see. What is this times that? Square root of 3 times square root of 3. Is it not 3, guys?
It's negative.
Yes.
Yes,
So
it is.
yes. Okay. Over 2 times 2 is equals to 4. So I wanted to say that negative with that negative, they cancel each other out. But let's write that in the meantime and say negative 1 over 1 is the same as negative 1 times. What is cos 90 minus that? Remember, 90 minus that, it falls in the first quadrant. In the first quadrant, is cos positive or negative?
It's positive.
It's positive. And then because it's 90 there, what does it mean?
It means that
Cos will change into sine.
Yes, then it means we have sine of 63 degrees all over. What is negative 1 times sine 63? Is it not negative sine of 63 degrees? I think it is. Let's see. So can you see what Grace was saying? This will cancel with that. And then you now have this fraction multiplying that negative 1, which means we actually have a
3
positive
over 4.
3 over 4. But remember, you are dividing by that negative invisible 1. So you still have negative 1 over there, which means in the end, you end up having negative 3 over 4. Does it make sense, guys?
Yes, sir.
Imagine 7 marks. 7 marks. It's a lot of percentage if you calculate it out of 150. So how do we prove if this answer is correct?
No, sir, I've just punched everything like the equation perfect. It gave me negative 3 over 4.
So that means, Shreyas, if you punch on a calculator, you start with a fraction button, and then you punch that, you times by 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 that. If your calculator is on degree mode, of which always you need to make sure that it's on degree mode, you are going to get your final answer or whatever that you punched being negative 3 over 4, which means you are going to score full 7 marks. Are you guys happy there? Can we now move to the next question? I think this will be our last question, and then from there, I'll leave the last one as a homework. But can we do the last question? But before we do that, are you happy there?
Yes, so we can move to the last question.
Last one to confirm, did you all understand that calculation?
Yes, sir.
Yes, sir.
Okay, 100%. So I'm just going to quickly remove all of this. I'll remove all of these, and then from there, we move to question 5.3, where they need you to prove that 1 over cos of that minus cos of that over plus sine angle is equals to tan angle. And this question is allocated 5 marks. Let's just make sure also for the last time that I've copied it correctly. Can someone just make sure that I've copied it correctly there and confirm for me?
Yes, sir, it's correct.
Okay. Is there anyone who'd like to give it a try?
So I think we're gonna cross multiply.
Okay, let's give it a try. So the left hand side, let's work it out. So you tell me what to write, honorable member. Who's speaking? You know, you guys, your voices are the same. And I end up feeling who's who. Who's speaking now?
Determination.
Okay, determination. Let's try to work it out. What am I writing?
I think we're gonna cross multiply. Firstly, just say maybe we could start with the cos.
Mm-hmm.
It's gonna be cos squared
Mm-hmm.
theta, and we're gonna say 1 plus sine theta.
1 plus sine theta. Mm-hmm.
No, I get we are cross multiplying. So I think we're gonna have the sign on the middle, but I'm not sure. Say I'm not sure, honestly speaking. Yes.
Eish. Manje siyenza kanjani apho ka mo exam monna wa ngwala ke tsebe go tlo re examiner na honestly speaking I'm not sure.
Okay, let's start again. Please erase that things, please.
Okay.
Mm-hmm.
Let's try.
1 plus sine theta
1 plus sine theta. Mm-hmm.
minus
Mm-hmm.
cos squared theta
Cos squared theta. Mm-hmm.
all over cos theta
cos theta.
open bracket
Mm-hmm.
1 plus sine theta.
1 plus sine theta. Hey, what are you doing there, determination? Wenzani lapho?
Selena, I'm just
Guys,
trying. I don't know. And I
guys,
think let's continue, say.
no. But before we need to check if you are taking us as Oluine or you are taking us the hailing. Urisha guy want determination. Guys, do you agree with what determination is doing there? Do you think we are going to heaven there?
So now I think determination would try to find out the LCD.
The LCD. But
yeah, but then we get it wrong, so
we
the
did it
top
wrong.
one.
The top
Yes.
one. Okay. So let's continue with this. We'll see where we end. But before we even continue determination, let's check how would honorable member there approach this one. What are you saying, Dumza? How are you going to work it out? The first step.
guess I was just thinking maybe ka answer determination. But say, LCD say it could cos theta. Yeah. Yeah, open bracket 1 plus sin theta.
1 plus sin theta.
LCD that one, Sane. Then
Oh, okay.
go dim. Draw a line, say, at
Over.
the top. No, at the top.
Hey.
Go dim.
Here.
No, say.
Where?
Go dim that cos theta. Draw a line. Yes. Go further. Over.
Oh, all over. Okay, no, I see.
Yes, then we're gonna say 1 into that equation. Go further. Is that equation?
Okay. Obviously, is that equation. So it's cos of that into 1 plus sine of that.
Minus that equation into cos theta.
So the whole of this times cos theta.
Yes, I think so.
Okay. So let me just give you guys a very quick response. Both of you guys are correct. What determination is done there? It's actually a shortcut of this, of which I will also teach you how to approach this type of a fraction, such that it straight away takes you to this. So you are right in doing that, or in saying you try to find LCD being the lowest common denominator and also working it out in that way. So determination, masichubeke. Tumza, did you understand my part where I was saying both of you guys are correct? This is the shortcut of what you were saying there.
Yes, sir.
Okay. Determination.
Say, I can't hear you.
Can you hear me now? Or maybe ke less speed. Wangkwano. Okare ka English ke kwa. Wangkwa. Hey. Tumza, can you hear me? Or
Yes, I
determination
can.
was out. She's back now. Determination. Can you now hear me?
Yes, sir.
Okay. Let's go.
So, Sam, continue. Okay, I get. So, now I'm not sure, being honest, and I don't know for this thing. It's a feel like I don't know, but I'm guessing. Yeah. So, yeah. I think I'm not saying. I think we're gonna change that course question.
But you are saying. You are not saying, but you are saying. What are you saying?
I'm thinking, sir.
What are you thinking?
Yes. 1 plus sine theta.
I like the way you say theta. It's like you're saying theta, you are saying Peter, you are saying theta. What are you saying? What are you saying? Determination.
Sir.
What are you saying? What is Peter doing there?
Matungseke engel.
Okay, so now we are having 1 plus sine theta. Then now, what do we do?
I think we're gonna change cos squared theta
Mm.
to one minus or one plus sign.
Okay. It's fine. Let me do it so that
Okay.
you are correct. Determine. I'm just suspecting that whatever that you'll be doing going down, it will lead us to the correct answer. But now, I just want to explain. I'm still going to write exactly this. So, for you to be sure of what you are doing, determination. I think on yesterday's lesson we did say, when you are proving identities, you look for where you have a tan to try and dissolve it such that it's sine over cos. And again, you want to reduce when necessary. For example, if that angle it was 180 minus theta, then you would try to reduce that angle to say in which quadrant it falls. Is that trig ratio positive or negative? Then you write it as an acute angle. And also, where you see that one exists on the equation, always know or remember that one is actually equals to a sine angle plus cos angle. Remember, a squared over there. So a always determination, if you want to know if it's 1 minus sine or 1 minus cos, firstly write it like this. Then you'll be able to know that where you see cos squared angle, just know it's 1 minus that, because when you transpose, it's 1 minus. When you see sine squared angle, you know it's 1 minus that. So now let's try to work out this one. Tumza the Tumza. If you remember, I said I'm going to teach you how to quickly work out a fraction. If you have 2 over, let's say, 3 minus, let's say, 1 over 4. This is how I used to do it. I just I multiply these two, and then from there I just cross multiply. I think I've done this one before, whereby I said this is the sign to work it out. What does this sign mean? It means 3 times 3. What is that? Is it not 12? It's 12 over, what is this times that? Is it not 8? Determination, the sign, you use the sign that is there. If it's a plus, you use a plus. If it's a minus, you use a minus. In this case, it's a minus. That's why you write that same sign. Then this times that is what? Is 3. So that means this minus that, what is that? It's 5. Then means finally, this thing is actually 5 over 12. So let's use the same sign, being that sign or that symbol. So that means it's this times that. Then you cross multiply. Let's see. What are we having? On the left hand side, we have this times that, being cos angle into 1 plus sine of angle. Then if you cross multiply, you have that times 1. So it's just the same as it is because you're multiplying it by 1. Then they say a sign is being used. Then you have this times that. What is that? This is cos squared angle. So now let's continue. What are we having there? So can you see there you have 1. So normally where I see 1, I can just replace it with a sine squared minus, plus cos squared, because I know 1 is the same as that. So what I'm saying is sine squared angle plus cos squared angle is the same as 1. Remember, you have this and that. So that means you still have plus sine angle minus cos squared angle. Remember, all of this divided by cos angle into 1 plus sine angle. I'm not sure. Did I lose you guys? Or are we still together with what I've done over there?
No, sir, I'm lost. Sine squared theta plus cos squared theta, where did they came from?
You remember, maybe let me write it again. So you don't want to be seeing tan on an identity. Also,
Oh, you said, oh, yeah, I
yes,
see. Okay.
yes. 1 always is equals to this. So that's what I was saying. Or the other one was the reduction. If you have maybe that angle being that. So you reduce where necessary, you dissolve tan where necessary. Also, where you see 1, you can choose to replace it with all of that. So you kind of like know what to do if you have done more of this type of problems. But if you haven't, it becomes a bit tricky for you not to know whether to replace that 1 by that, or maybe replace that by 1 minus whatever. Whichever one that you do, it will still lead you to the right destination. We'll give it a try and check if with different approach it will give us the correct answer. So everyone, are we together there?
Yes, sir.
Okay, so do you agree that you have 1 cos squared x minus 1 cos squared x, they cancel each other out? Do you guys agree there?
Yes, sir.
Yes.
Which means you remain with sine squared x plus sine angle there, cos of angle 1 plus sine angle. I hope you guys agree with me on that one. Obviously, you can see where this is going. It's almost done. You have sine, you have sine. You can take it out as common factor as sine angle into there. Obviously, you are going to have a sine angle plus there you've got invisible 1. The whole of this divided by cos of that. Do you guys agree that 1 plus sine angle is the same as sine angle plus 1? Do you guys agree with me on that one?
Yes, sir.
Yes, sir.
Someone is laughing. It's because it now seems to be easy, isn't it? Because that cancels, you remain with sine over cos. What is that? Is it not tan?
Yes, sir.
It's tan. So can you now see that we have proven that the left hand side is actually equals to the right hand side being tan over there? Quickly before we wrap up the lesson, can I try to do it the determination way? Let's try to see. So determination said she was going to say 1 plus sine angle minus. She knows that cos squared angle is actually the same as 1, being that one you transpose, then it's minus sine squared angle close. Am I correct in saying that determination?
Yes, sir. But, sir, you're gonna think that I'll give it dumb, sir, because I already know what is it going to be? You're gonna change that one.
So
Um,
it's more like a. So I just wanted to show that also with your approach, it's
mm,
correct because um, it doesn't matter whether you replace that one by the whole of that or you replace that by this. You just need to be careful that this negative is that negative and then everything inside the brackets there, which means you end up having 1 plus sine angle that times
okay.
that is minus 1, that times that is positive sine squared that over cos angle 1 plus sine that. So can you see 1 minus 1 cancel each other out? Then you remain with sine that plus sine squared that all over that, and that. So easy, easy, easy. You take out that as a common factor there. So you obviously end up having sine that into what is it? There is 1 plus there, what is it? You end up having sine angle over cos of that, and that, that, and that over that is equals to that. Therefore, that is equals to that. Did it make sense to everyone? Are you guys happy there?
Yes, sir.
Yes, sir.
Okay, guys, this brings us to the end of our lesson for today. I'm not sure if there's someone who's got a question before I sign out.
No, sir, wait, I'm still writing.
Tumza, what did you say?
Sir, I'm saying I'm still writing. Don't
Oh,
erase.
okay. Anyone who's got a question? Or are you happy? Are you fine then?
Yes, sir, I'm happy.
Lungster, Grace, are you okay that side?
I'm happy, sir.
Gracie, I know Gracie has got some issue with the network, but I'll just make an assumption that she got it because she's been with us since the beginning of the lesson. So, guys, thanks very much for joining. I hope you did enjoy as much as I did. My name is Desmond, and I'm out.
Thank you, sir.
O feditse go kopolla, Tumza?
Oh, yes, sir, thank you.
Okay. Cheers, guys. Cheers, Yele.